Alright, morning class. So today lecture will be on about forces. So it's a bit different from what you have learned earlier. What you have learned earlier is more about identify what type of load acting on structure. So this class is more about analysis of force. Alright? So what you're going to learn today is first classifications of load. So we have dead load, live load, snow load, wind load, earthquake load, residual and settlement stresses, thermal stress. All these I suppose you have learned it before, right? So next we are going to learn unit of measure and equilibrium as well. Alright, so what is the function of building? The function of building is never to take all the load, yeah, by the way. The function of building is actually to transfer the load. We are inside a building, so we stand on the floor. The floor will take the load, but eventually it will transfer to the foundations. Right? The floor itself will never resist the load. Okay? So, what are loads that act upon a structure? So we have no load, gravity load, seismic load, wind load. Okay, snow load and rain load, basically it comes from top. It acts at the top part of the building, roof, and then transfer it down. Gravitational load is the same. Wind load, what about wind load? Gravitational load, we have dead load, we have live load. They are acting on top vertically down, right? Right? What about wind load? What about wind load? Sorry? Horizontal. In the actual fact, wind load is something very interesting. So it can result load in vertical direction. It can as well result load in horizontal direction. First thing you must understand about wind is it comes in various directions. Isn't it? Alright? There's a reason why wind load sometimes it can cause vertically upward force, sometimes downward, sometimes horizontal. Okay, I will show you that later. What is seismic load? Sorry? Ground movement, yes, what else? When we talk about ground movement, something just recently happened. I think yes? Yes, earthquake. So, have you wondered how earthquake force act on a building? Have you ever studied how earthquake force or the seismic load acting on a building? Let's say this is the building, right? The force is actually coming from the bottom because earthquake, ground movement. So the load is actually transferred from the foundation and upwards. So this is how it acts. So if you try to Google some videos about building or some videos about earthquake or earthquake analysis of a building, so you will actually see that they actually have this model screw to the foundation and then shake the foundation. So this is the movement of building. So the horizontal force is transferred upwards. Alright? Okay, so these are some basic loads, and what else we have? Earlier on, if you look at the list, over here I also mentioned about residual and settlement stresses. What is settlement stresses? Settlement stresses is significant when you have a different settlement rate. One part of the building settles faster than the other one. Then the building starts to tilt. Alright, so it will result in stresses. That one, when there is stress, meaning to say there is force. Alright, what about thermal stress? What What's that to do with thermal stress? This is significant in bridge structure because bridge is actually exposed to sunlight, exposed to environment. So there will be the contraction and expansion effect or action due to the temperature. Alright, so another type of load that we account for is accidental load. Accidental load we don't really design for a building, but when you go to the car park, have you parked your car somewhere in the open car park, elevated car park? You will see that there is a parapet wall, right? That parapet wall is never a brick wall, yeah? It's actually RC wall. It's actually reinforced concrete wall. There are reinforcement bar inside. The reason is to resist accidental load. Alright? So if you use brick wall, this is the result. The whole thing is going to collapse. Okay, but again, it depends on the impact. If the impact is too strong, even the RC wall also it will collapse. But of course, it will perform better compared to brick wall. Alright, so next move on. So, in this picture, can you identify what are the dead load that you can see? Just a simple cross section. Tell me what are the dead load that you can identify. Come on. Walls, what else? What are the dead load that you can identify? Dead load. You know what is dead load, right? Do you know what is dead load, class? What is dead load? Yeah, so immovable load. As long as you put that, it will stay there forever, the building stands, then that is dead load. So in this picture, what do you have? We have brick wall, yes, of course. What else? Roof, yes. What else? How many of you in the class? Okay, come on. What else? What other dead load you can see? I need at least 5. I have wall, I have roof, what else? Columns and beams, yes, that is the structure itself. Yes, correct. What else? What else? Someone told me the toilet bowl is, but unfortunately it is not. What else? Floor, slab. Okay, floor is considered as a structure itself. 2 more. What else you can see? Okay, stairs. Stairs is also considered as a structure itself. 2 more. Something that you attach to the structure permanently. No, not chimney. Chimney is the structure itself. Something you attach to the building. Sorry? Water tank? Fan. Fan is categorized as? Huh? No. Furniture is movable. Fan. What we have here? Not really. Lighting is considered as what? As services. Services. That is also considered as dead load. Another one. No, not really. What is this? What do we have here on the floor? We have carpet is actually one of the floor finishes. All right, floor finishes, services, the building itself, brick wall, and then the roof. All right. So these are the dead load. So this dead load, right, is actually the easiest to calculate. Why? Because we have all the dimension. Yeah, we apply flooring onto the floor. So we know that how much mortar we have to put in. We know what is the weight of the floor tiles or whatever material you are using, isn't it? So dead load is actually the easiest to calculate. Provided you have the size, you have the density of the material. Usually, the density of material will be provided by the supplier. All right? So, sometimes calculation can be complicated. It depends on what are the unit given to you. We'll talk about unit later. So sometimes, for example, masonry wall usually is given in terms of a weight per square meter. So brick wall, standard brick wall, the load is given in terms of every meter square, in terms of height, every meter square, what is the weight? Okay? For analysis purposes, the dead load is usually assumed to be on top of the beam. So, yeah, okay? Next one is where we can get the density. The density of material is usually given in attached in standards or codes. So this is actually part of UBBL. Heard of UBBL, right? Yes? What is UBBL? Do you know what is UBBL? Okay. So Uniform Building Bylaw. So you look at for, I think, Schedule 4. Try to look for Schedule 4. So all the density of the common construction material is actually listed in Schedule 4. Do you have it? Schedule 5. Sure. All right, either Schedule 4 or 5. All right, so this one, they give you, let's say, okay, concrete. What is the density of concrete? Concrete categorized into two different types, unreinforced and reinforced. So unreinforced is 23 kilonewton per meter cube. Look at the density. Look at the unit weight. Look at the unit. So this one is kilonewton per meter cube. For unreinforced concrete, it is 23. For reinforced, it's 24. Reinforced concrete is heavier because of the steel content, because of the reinforcement bar. So they also give you what is the density of steel, gravel, earth. So this is important when we have the planter box. So basically, the architect will design. So you all will design what is the height of the soil to be put in, what is the height of the planter box, something like that. Then the engineer will have to calculate, okay, what is the load acting on the building. So this one is another, I think, another section. This one, the difference is that the density of these materials are given in terms of Newton per meter square. Just like what I said earlier, it is per meter square. For every meter square, what is the weight rather than density, rather than per meter cube. All right. So roof tiles, they further categorized into two: terracotta and concrete. So 580 Newton per mm square, meter square. So you have to check what is the density, what is the unit given. So far so good? All right, next move on to live load. Live load, what is live load, by the way? Live load, imposed load, movable load. All right. So when we to identify live load of a building, or rather of a space, it depends on the function. Live load is never depends on how many furniture you put in, how big it is. No, it depends on what is the function of that space. If let's say this room is basically for bedroom, the live load will be slightly lower compared to probably a lecture theatre, because of the density of human inside the space. Bedroom probably will have 1 or 2 packs, maybe 3 or 4. But in a lecture hall, we can have more than 10, more than even 50 or 100. All right? So it depends on the function. So I think refers to schedule 4. Again, UBBL. They have a long list. So all the potential functions of a space is listed. So I show you one example, bedroom. So look at bedroom. So we have domestic building, hotel, institutional building. So it is 1.5, 2, and 1.5. All right. So that space, meaning to say, look at the unit given. It is kilonewton per meter square. It means, let's say for example, this is a bedroom. For every meter square, every 1 meter by 1 meter, is going to take 1.5 kilonewton. So far so good? All right. So there is another code which is not so familiar to you all, which is BS6399. All right, look at the last sentence, last point, BS6399. This is also one of the code that state all the potential, all the live load. All right. These are the two common load or standard that we are using in Malaysia. All right, so next one. Just now, earlier on, I talked about wind load. So wind load, it can actually impose vertical load, it can impose horizontal load, and why is it? It can result pressure, suction, and friction. So to analyze wind load is very interesting because you have to understand what is the aerodynamic actions. So I show you one example. This is a simple example where this is the plan view of a building. So the wind actually coming in this direction, in the horizontal direction. Okay, the wind comes in this direction. So when it passes through a building, what happens is that it has to divert because it cannot pass through. When it comes to this building, it cannot pass through the building, so it has to divert the direction. And when it diverts the direction, it will result suction at the side. Suction over here and here, then suction at this direction as well. Alright, if you look at the elevation view of building, this is where the direction of the wind comes from. So again, when it comes to the building, then it will have to divert the direction. Alright, when it diverts the direction, then it will result suction at the roof and suction at the other end. That's the reason why sometimes when we have a storm or strong winds happen, you will see that the roof tends to fly away. It is not because it's not because of the overhang part. It's because of the suction force. And sadly to say, in Malaysia, the roof is never properly designed for the connection part. The roof sheet is basically just to bolt down to the purlin, all right, just by using standard detail. They never check. That's the reason why when strong wind comes, there are a lot of roof tend to fly away. All right, so basically these are the 3 basic load that you have to understand. So seismic load, thermal stress, even snow load. Snow load is not applicable in Malaysia, but in overseas, they will tend to check by using this slope. Let's say, for example, by using this gradient, what is the potential height of snow that will accumulate on top of the roof? Then they calculate what is the load accordingly. All right. So seismic load, thermal stress, all these are too technical for you all. You just have to be aware of it. So next one is unit of measure. So load is applied on building in these three different ways. So first one is point load. So can you give me an example? What will result a point load on a building? Sorry? Car. Column. Yes. However, it has to be column on the beam or column on the floor. If it is column onto column, then the transfer mechanism will be direct. Okay? So column on a beam or on the floor, it will result a point load. Yes, correct. What else? Do you know what is MRI machine? MRI machine, yes? No? Is a medical equipment where they scan the body, something like that. So try to Google about MRI. So MRI machine is a very heavy machine. So when you put on the room, in the room, what happens is that it will also result point load. Alright, it's very heavy. However, let's assume that when I'm standing here, yeah, I impose point load onto the building due to my weight. However, we do not analyze the human weight one by one, no. Alright, so the human weight is analyzed as this area distributed load. Across this area, what is the density of people, and then we apply the load. Alright, it's over an area. So this one, the unit is kilonewton per meter square. So another type is line distributed load. What is line distributed load? Can you give me an example? Look at the name. As the name suggests, it is actually in a line. So what will result a line distributed load? Yes, brick wall. This one. Alright, this one. Human load spread across an area. That's why it's area distributed load. Even the furniture as well as the floor, the floor finishing, even as well the services. Okay? Alright, so just bear in mind we have three types of load. This one, point load, basically act on column. This one, basically the load act on beams, because beam is a long element, and area distributed load basically it act on a flat. Alright, so next move on to force. So force, these are just very basic introduction. It's a push and pull actions. So it's a vector, so the magnitude and the direction, it matters. And indicated by using arrow. Force is also equivalent to mass times acceleration. This one is based on Newton's second law. And then we have unit of force, which is Newton or kilonewton. In building, in structural analysis, we do not use Newton. Newton is way too small. Alright? We use kilonewton. Alright, so next. So just a simple structure. Let's say I have this structure. It's subject to 100 kilograms. How we convert it into Newton? Do not apply 100 kilo onto a building. Apply the force resulted. So to convert 100 kgs into force, I hope you know this. The weight, the mass times gravitational acceleration, 9.81 or equivalent to about 10. So we'll have 1000 Newton, so equivalent to 1 kilonewton. So replace 100 kg by 1 kilonewton. Alright? So that's how you convert mass into force. Alright. So in any structure, force can be applied in various directions. We have core planar force and we have non-core planar force system. Core planar force means that all the forces act on the same plane. You look at F1, F2 and F3. Yes, F2. Okay. You look at F1, F2 and F3, the line of action are actually lie on the same plane. It's actually on the same surface, in other words. If you look at this one, line of action do not lie on the same plane. So you have F1, F2, and F3. They are actually acting on different surface. Do you notice that? So I call this a 3D arrangement. So far so good? Alright, so next one. Here there's a question. When it comes to structural analysis, coplanar force or non-coplanar force analysis is commonly adopted. Which one? So when we want to analyze a building is a 3D building, of course. So when we analyze a building or any structure, so we use coplanar force or non-coplanar force. And why? Coplanar is 2D, non-coplanar is 3D. Why? Which one? Sorry? Non-coplanar. Anyone else? Everybody says agree? Everybody agree non-coplanar? In actual fact, we use coplanar force analysis. Why? Let's look at this diagram. This is a 3D structure, but do you notice that 3D structure we can further break it down into 2D frames? You notice that? Here there is a frame. The red color plane is actually one frame. The yellow one is another frame. So coplanar forms are commonly adopted because it's much easier. We have only 2 dimensions, the vertical and the horizontal, that's it. Okay? However, nowadays with the advancement of technology, the engineers will also analyze non-coplanar force by using software. Alright? If do manually, 3D is just way too tedious. Alright? Alright, so next move on. So other than the force system, we also have another 3 terms: collinear force, non-concurrent force, and concurrent force. So collinear force that have the same line of action. The line of action are actually the same. Can you tell me which one? Which pair that actually have the same line of action? F5 and F4, these act in this direction, F4 the other direction. Are they collinear? No. Alright, then which one? There's only one pair. Anyone? No? F what? There's a pair of force which have the same line of action. F what? F4 and F6. F6, the line of action is here. F4, the line of action is here. How can it be the same? When I say same, it doesn't mean same direction. It means same line, exactly the same line. It should be F6 and F3. Alright, do you notice that they are actually having the same line of action? Alright, they act exactly on the same line. F3 is coming in this direction, F6 is that direction. Alright, so next move on. Non-concurrent forces that do not intersect. These 2 forces that do not intersect at all. Non-concurrent force. I'll give you an example. F3 and F3 will never intersect with which force? F what? F5, and it will never intersect with F4 as well. It will never intersect with F10 as well. Isn't it? Right? Okay? So, next one is concurrent force. What is concurrent force? Concurrent force refers to forces intersect at a common point. Meaning to say they are going to intersect at one point. Very simple. So which one? F3 and which? F3 and intersect. F what? What's the answer? 9. 9. Be confident, yes. F3 and F9, F3 and F1, F3 and F2. They will intersect at one point eventually. Alright, that's what we call as concurrent force. So far so good? Okay? Alright, let's move on. Okay, so when we talk about force, right, we need to understand how to analyze or how to add them together. So it refers to vector operation. I hope that you have learned this earlier. Yes? No? Okay, anyway, let's move on. So a force is a vector quantity. It has magnitude, direction, and point of action. So meaning to say, force, it has magnitude, refers to what is how strong the force is. Let's say 10 kilonewton. 10 is the magnitude. Direction, in which direction it acts on. So always remember to indicate the direction by using the angle. And angle is always start from the positive axis. Alright? So point of action. This force act at which point? That is also very important for force. Okay, to indicate that it is a vector, it is usually indicated by all this. F with an arrow on top, underline or bold it. Alright, so next move on. So to add forces act in the same direction is very straightforward. For example, I have a particle here. So I pull it I pull it by using 50 kilonewton and then push it by 100. The effect will actually same with you pull it by using 150 kilonewton. This one, do you get the idea? Yes? So 150 is actually what we call as resultant force. Alright? That is the result when you add two forces together. So far so good? And it is so far so good? Alright? Alright, so next move on. So next one. So earlier on the example show you something in the same direction. What about in the opposite direction? So you just minus off. You pull it by 50. Someone pull in the other way by using 20. So the effect will be similar to pulling in 300 by using 30 kilonewton. Alright, so to simplify things, right, we use Cartesian system, which is positive x, xy system to indicate the direction. If it is in the positive x direction, then it will be positive. Negative x, then it will be negative. Y will be upward will be positive. Downward will be negative. Alright, so another example, again, very straightforward. So the resultant force is actually negative 270 kilonewton in y direction because the force is going downward. And it doesn't matter whether this force is acting on top of the particle or below the particle. Basically, they are having the same effect. They are exactly the same. Alright, so far so good. Okay, so next. Just now, all the examples show you something in the same direction. What about in different direction? I have slanting force, FA and FB. So FB is 300 kilonewton or 35 from the horizontal axis. And 100 kilonewton FB, 45 from the horizontal axis. So some of you might have learned this before. There are a lot of different ways to actually solve these questions. We can have triangle rows, polygon rows, and resolution of force. So what I will do in this class is more on resolution of force. So the overall idea of vector operation is to resolve the force into x and y axis. It must be in x and y component. Okay. A single force can be replaced by earlier on, where we have this example show us how we can combine two forces into one force. The result is a resultant force. Similarly, we can also derive, or we can resolve this 270 into few different forces. It can be 250 and 220. It can also be 270. It can 170 and 100. All right? So that process is what we call as resolution of force. A single force can be replaced by two or more forces that produce the same effect. Resolution of force. So these forces are called as component of a force. Let's look at this one, Fa. I can resolve Fa into Fax and Fay. So Fax and Fay is the component of Fa. Alright? X component and Y component. There could be infinite pairs of components. Just like earlier on, I said it can be 170, 270, and so on and so forth. However, in order to simplify structural analysis, forces is usually resolved into a component X and Y. Only X and Y, nothing else. So far, so good? Okay? So, in order to perform this, you have to recall what you have learned way long ago. You have the sine theta, cos theta, and tangent theta. I'm not going to go through all this because these are the basic which you have learned already. So if you are not sure about this, Google it. Ask your friend. So another theory that you must understand is theorem Pythagorean. Pythagorean theorem. So where Fr equals to Fy squared plus Fx squared and square root. Alright? So I hope you still remember A squared equals to B squared plus C squared. That's the right angle triangle. So far so good? Alright, let's move on. Okay, so let's try to solve this example. Resolve the following forces into X and Y component. So when we say resolve it into X and Y component, meaning to say, just take it as there is one force, I have to split it into X and Y component, that's it. Okay? Easy? I have to split it into X and Y component. If you were given two forces, you will have to do the same for two forces. So meaning to say, Fa, I have to resolve it into X and Y. Fb, X and Y as well. So far so good? Alright, so let's look at the first one. So Fa equals 200. It acts on 35 degrees from the horizontal axis. So try to construct this right angle triangle. So you have force going upward. So the horizontal force will have to go to the right and going up. So this is the right angle triangle that you have. Your 35, the angle given is over here. So sine theta equals to Fay over Fa. Opposite over hypotenuse. Angle is here, this is opposite. This one will be hypotenuse. Right? So far, any questions? No? Okay? Alright. So, you just put in the info. Sine 35 equals to Fay. Y component is something that you're looking for, which you are not sure. So, leave it as it is. Divided by hypotenuse, which is 200 kilonewton. So, you rearrange everything. You will have Fay equals to 114.7. Because Fay is acting upward. That's why it is a positive. Alright? So now, look for X component. X component, cos theta equals to Fax over Fa. We are using cos because cos involves adjacent. So the adjacent is our X component. Equals to, so put in all the info. Cos 35 equals to Fax, which is unsure, leave it as it is. Divide by hypotenuse 200, rearrange everything, you will have Fax equals to 163.8 kilonewton. If you have this calculator, You can actually check it right away. So far, okay? All right. Okay. some of you may find it a bit confusing to actually how to decide when should I use sine or when should I use cos. So I tell you one simple rule. Okay, so this is the angle given to you. This is the angle given to you. If you are looking for the component, if you are looking for the component which is FAX that attached to the angle, we use cos. Okay, I repeat, if you are looking for the component that is attached to the angle, so let's say for example, I'm looking for FAX, and this FAX is attached to the angle, is next to the angle, then we use cos, or otherwise we use sine. All right? Okay. So this is what we found. Next, we have to perform the same for FB. So FB is 100 kilonewton. Again, construct the triangle, right angle triangle. Look at the direction of the force. So it's going towards this direction. It's going towards this direction. So the triangle you construct, it must go into this direction, the negative x direction, and upward. All right? So again, if you are looking for FBX, FBX is the one that attached to the angle, or next to the angle, we use cos. That's why you look at here. FBX equals to 100 times cos 45. If you are looking for FBY, which is not attached to the angle, automatically we use sine. So look at here, FBY equals to 100 times sine 45, and we got 70.7. So far so good. And why FBX is negative? Why FBX is negative? is because it moved to the left. All right, negative x direction. All right, so what's next? So what we have done so far is we were given this force, FA and FP. What we have done so far is we resolve them into their component, which is x and y, FAX and FAY, FBX and FBY. So now all the forces are in the same direction. So what we can do is that we can sum them up, add them together. So the summation of force in x direction equals to FAX plus FBX, only the x component. So FAX is 163.8 to the positive direction, and FBX is to the negative direction. That's why you have resultant force, which is 93.1. Only x direction. Do the same for y direction. Summation of force in y direction equals to FAY plus FBY. So add these two forces together, 114.7 plus 70.7, you have 185.4 kilonewton. So far so good? So what we have done so far is we add all the x force and y force together. And this is what we have. We know that the sum of force in x direction is positive direction, 93.1. And y direction is positive as well, which is 185.4, going up. Okay? So now it's time to find the resultant. Earlier on, I resolved the force, every single force, into x and y. Later on, I combined it. And now I combine these two forces, x and y, into resultant force. How I find resultant force? It is by using Pythagoras theorem. Alright? Which is fx squared plus fy squared square root, and you get 207.6 kilonewton. So far so good? Alright. So this is the force, the resultant force that we found. However, this is insufficient because you have to tell me the direction. Don't forget the direction. So you by using tangent rows, tangent functions, then you'll find that theta equals to 63.33. 63.33 is over here. Okay? So far so good? Questions? Okay, no questions. So let's look at example 2. So this is an example. Let's try to solve it. All right, you were given 5 minutes for this. Try. Okay, have you found the answer? The answer is resultant force is 107.8. Alright, the resultant force is 107.8. So I have the calculation here, later you can get it from me. Alright, so next. Okay, so next, let's move on to movement. So the point of application of force can be very significant. The point where the force is applied is very significant. Alright? So I want to show how important it is by using this merry-go-round. So everybody knows what is merry-go-round. So let's say I apply 3 different forces on merry-go-round. F1, F2, F3. Alright? Let's say 1, 2, and 3. Alright? Which force can actually rotate merry-go-round? Which one? F1, F2, F3, 3 different forces apply on this merry-go-round. Which one can actually turn the merry-go-round? Or make it start to move? Which one? You all played this before, right? No? Yes? So which force will actually turn the merry-go-round? Will make it start to move, start to rotate? Which one? F2, F3, or F1? Which one? It's actually F1 and F3. Alright, F1 and F3. Why? It is because F1 and F3, it can result that it is a distance away from the point of rotation. So it will F1 and F3 will actually create a moment which which makes the merry-go-round start to move, while F2 it doesn't. Alright, how this works? It is due to the moment. So to calculate moment, 2 components you need. So the first one is line of action and the rotation point. So moment is given as force times distance, where distance is the perpendicular distance. So if you look at this diagram, just now I said force 1 can actually make the merry-go-round to rotate. Why? It is because this force it is just a horizontal force, but when it applied to this structure, it will create a moment. So this force acts in this direction, and it is a distance away from the point of rotation. So this is the perpendicular, this is the line of action for force 1. Alright, then it is at a certain distance away from point of rotation. Alright, so this force will actually create a moment. Whereas if you look at F2, so this force, it acts directly on the point of rotation, or along the same line of point of rotation. So there is no distance between this force and point of rotation. That's why there is no moment. Moment is not created. That's why the structure doesn't move or doesn't rotate. So moment is something to do with rotation. Same force, but you apply at different location, it will create different moment. Okay? Alright. So F1 and F3, it will turn the merry-go-round. So does the vertical one. Alright? Alright. So next, let's move on to Newton's law. So simple one. There are 3 laws. The first one and the third one is something that of our concern. So an object at rest will remain at rest unless acted on by an unbalanced force. So it will remain as rest, or it will remain moving until an unbalanced force or an extra force acts on it. Alright, so the second one is force is produced when acceleration acts on mass. So F equals to ma. So last one is for every action. For every action, there is an equal and opposite reaction. So let's say if we are standing on the ground or on the floor, we have our weight. So the weight will create a force acting on the floor. So how the floor reacts is that it will create a reaction force, which in the opposite direction but of the same amount. Alright, so equilibrium, according to law of mechanics, any motion can be described in terms of a combination of translation and rotation. So building is a static structure, so it doesn't move. It doesn't move. What I mean by it doesn't move is if you build it here today, it will not move here tomorrow. That's what I mean by it doesn't move. However, the beam, of course, that will move slightly. Alright, so it should remain at rest all the time or in the state of equilibrium, meaning to say all the force act on this structure, it must be balanced by a reaction force. Reaction force at the foundation. Okay. Alright, so another example to show what is equilibrium. So you look at this person is stand on this structure. So what happened is that because there is an opposite or there is an equal amount of reaction force occurs, so the summation of force in y direction is equal to 0. Alright? So there is no horizontal force acting on this person, right? No horizontal force. That's why summation of horizontal force is equal to 0 as well. So next, so this person will remain in balance. Alright? It will remain balanced. So next one is, what about this? The summation of force as well is the summation of force in x direction 0. The summation of force in y direction is also 0. But would this person stay stable? Would he be stable? Why? Isn't it equilibrium summation of force must be equal to 0? Right? Earlier on our slide says it should remain at rest in the state of equilibrium. So everything must be in 0. Thus resultant force acting on the structure must always be 0. So look at the second scenario. Why it is not stable? It is because of moment. It's because of moment. The way the load applied on this structure, it is a distance away from the point of rotation. That's why this person, it will actually rotate, or in other words, it will start to fall. Alright? Because the summation of moment in this scenario is not equal to 0. That's why it's not stable. Got it? So what I'm trying to point out here is, in a structure, for any point of a structure, the summation of force must be equal to the force in x and y direction must be 0, as well as the moment. Alright, as well as the moment. So let's try to calculate this. Determine if the object shown is in equilibrium. So we have this object is subject to two different loads. So we have FA going up, FB going down. The amount is equal 100. So the summation of force in x direction obviously is 0 because there's no x force. So summation of force in y direction equals to 0 as well because 100 going up, 100 going down, so it's equal to 0. Lastly, you have to check what is the moment. So moment is a vector, so it has direction. So in my class, what I usually do is that I use clockwise moment as positive moment, and I use anti-clockwise moment as negative moment. Alright, so let's try to check the summation of moment at one particular point. At one particular point, which is, let's take 0. Let's say we check the moment at point 0. So, FA going up. Okay, look at the arrow of my cursor. FA going up and rotate about point O. That is the moment created. So this moment is in which direction? Clockwise or anti-clockwise? FA going up rotate about point O. So that is an anti-clockwise or clockwise moment. It is an anti-clockwise moment. That's the reason why I have a negative here. Yeah, 100 kilonewton is going up. Yes, I know. But the moment created by this force is negative direction. That's why I put a negative here. That's why negative 100 times 2. Negative moment. So far so good? So now let's look at the red color force. So this force, FB, it goes down. Yeah, I know that it goes down. But the moment created by this force is actually in positive direction, isn't it? It's clockwise. That's the reason why this is positive. Alright, every semester student asks this question. Might as well just explain. Alright, so 100 times distance, which is 3.5 meter. So you have the summation of moment equals to positive 100 kilonewton meter. So this is the unit for moment, kilonewton meter. And the conclusion is the object is not in the state of equilibrium. Because, yeah, it doesn't move left and right, it doesn't move up and down, but it will rotate. Okay, so far so good? Alright, that's about moment. So we still have last part, which is support. So in structural analysis or any building, all the support, all the joint, let's say for example, this column, this beam joined to this column. Alright, what we do is that we assume this connection as one support. All this connection or the support and even the foundation are categorized into 3 different types of support. So we have roller joint, we have pin joint, and we have fixed joint. So every joint will behave or act differently. So let's look at the first one, roller joint. Reaction force in single direction. You look at this structure, you will notice that this structure, this support allowed the structure to move left and right. Am I correct? Right? There's a roller. That's why it can move left and right. When the movement is allowed, meaning to say there is nothing tied to tie it back. Am I correct? There is nothing to tie it in this direction. Oh, get the idea? When there is no restriction, no movement restriction in that direction, meaning to say there is no reaction force because it allowed the structure to move. There is no reaction force. There's nothing to tie it back. So how to react? Logic? Okay? However, you look at this support, does it allow the structure to move up and down? No, basically it's bolt down, yeah? You look at this image, there is a bolt, screw the support down. So meaning to say, it holds it in place. It does this structure, it can move left and right, yes, but it cannot move up and down. When it cannot move up and down, meaning to say there is something to tie it back, am I correct? When there is something to tie it, meaning to say there must be a reaction force. So far so good? So all these symbols are actually the symbol to indicate that is a roller support. So when you see a roller support, always remember there is only one reaction force, which is the vertical one. Of course, if you put this horizontally, you rotate it, then the restriction or the reaction force will be in the horizontal direction. Alright? Okay, so this support, it cannot take moment. So what happened is that this support, it is allowed to move left and right. It is restricted in the vertical movement. And at the same time, it is allowed to rotate. Alright, it is allowed to rotate. So next one is pin joint. So pin joint constrain the structure against any translation in any direction, meaning to say it doesn't allow any movement in X and Y direction. It cannot move left and right, it cannot move up and down. So when it cannot move left and right or up and down, meaning to say there is restraint. So the reaction force will be in 2 directions, horizontal and vertical direction. Okay? Horizontal and vertical direction. So the support is, this is the symbol that we use in structural analysis to indicate what is, it is a pin support. Okay? The same goes to roller joint. this joint basically it allowed rotation. All right, it allowed rotation. When the rotation is allowed, meaning to say this support, it does not take moment. All right. All right, so the last one is fixed joint. Fixed joint can provide reaction force and moment in any direction. Fixed joint is the strongest joint. So fixed joint we usually use on cantilever beam where no movement is allowed. That's how you differentiate pin joint and fixed joint. Fixed joint because it doesn't allow movement. It doesn't allow rotation, which means this support can actually take moment. The earlier two, they cannot take moment because they allow the rotation. Fixed joint, it doesn't allow rotation, that's why it takes moment. Alright, so far so good? Okay, these are the basic of force and simple introduction to state of equilibrium. So here I also attach an exercise. So you have two exercises here. So these are the two exercises. So please practice and submit by next week. Alright, submit by next week. Alright, that's all my class. If you have further questions, you can come forward and ask. But don't ask me something about trigonometric functions, no. That one you have to study at your own. Oops. You all still want to take pictures? Alright, so this is the answer for the example 2 earlier. Alright, someone come and take it. Alright, that's all for today.